For the first time in 27 years, the moon is about to swallow the sun over mainland Europe. Not a partial nibble, not a thin crescent dimming the afternoon light. The real thing. Total darkness in the middle of a summer evening, while millions of people stand outside and watch the sky do. Something it hasn't done over this part of the world since 1999. And for Spain specifically, the wait has been even longer. The last time this exact stretch of the Iberian Peninsula stood inside the moon's shadow, the year was 1905. Your great-great-grandparents might have seen it. Nobody alive today has. On August 12, 2026, that changes. A narrow ribbon of darkness, roughly 300 kilometers wide, will race across the Earth's surface, starting in the remote wilds of eastern Siberia, sweep over the Arctic Ocean, cut through the glaciers of eastern Greenland, brush the volcanic west coast of Iceland, and then, in its final and most dramatic act, come sliding down out of the Bay of Biscay to paint a diagonal line across northern and central Spain, clipping a small corner of Portugal before finishing over the Balearic Sea near Menorca and Majorca. The whole spectacle, from the moment the moon's shadow first touches Earth to the moment it lifts off again, lasts about 4.5 hours. But if you're standing in exactly the right spot, the part that matters, the total eclipse itself, the few minutes when day turns to a strange twilight and the sun's ghostly corona flares out around a black disk in the sky, that part lasts at most 2 minutes and 18 seconds. 2 minutes and 18 seconds. That's the maximum, and only for observers standing precisely on the center line of the path, out over Greenland's ice fields where the geometry is most favorable. By the time the shadow reaches Spain, several hours later, the Earth has rotated the peninsula further. From that ideal alignment, and totality shrinks. In Galicia, where the shadow first makes landfall on the Spanish mainland, totality will run close to 1 minute and 45 seconds. By the time it reaches the Balearic Islands, where the sun is setting almost directly into the shadow's path, the window narrows further still. Every kilometer along that track has its own number, its own precise slice of darkness, and eclipse chasers have spent years mapping it down to the second. Here's what makes this eclipse different from almost every other total solar eclipse in living memory. Timing. Most total eclipses happen with the sun reasonably high in the sky, giving observers a wide, comfortable view with an open horizon in every direction. This one doesn't. Because of the specific alignment of the moon's orbit and the Earth's rotation on this particular August evening, totality over Spain arrives right at the tail end of the day, with the sun hanging low, sometimes as low as 4 to 10 degrees above the horizon, depending on exactly where you're standing. On the northern coast, near A Coruña, the sun sits a little higher, maybe 10 degrees up. By the time the Iber shadow races southeast to the Balearic Sea, the sun has dropped to barely 4 degrees above the water, meaning the eclipsed sun will hang almost directly on top of the horizon as darkness falls. That single fact changes everything about how you have to plan for this event. A high sun means you can watch from almost anywhere with clear sky overhead. A sun sitting practically on the horizon means you need a clean, unobstructed view to the west or northwest. No mountains, no forests, no tall buildings, no ridgeline quietly stealing the last few minutes of the show right when it matters most. And Spain, it turns out, is not an easy country for that requirement. It's the second most mountainous country in Europe, after Switzerland. Astronomers and eclipse guides have spent months publishing detailed elevation maps, warning people that the wrong hillside, the wrong tree line, the wrong hotel balcony could mean losing totality entirely to a wall of rock or timber standing between you and the setting sun. So where are people actually going? The path of totality threads through Galicia, Asturias, Cantabria, the Basque country, and then across the northern plateau through Castilla y León into Aragon, down through the Valencian community, and finally out across the Mediterranean to the Balearic Islands. Cities that will experience full totality include Bilbao, Santander, Burgos, Valladolid, Zaragoza, and Valencia, along with León and Oviedo closer to the western end of the track. Astronomers keep pointing to the interior plateau, places like Burgos and Palencia, as some of the best positioned sites in the entire path. Not because they're the most scenic, necessarily, but because the terrain there is flat, elevated, and dry, giving both a clear horizon and historically the best odds of clear skies. One well-known eclipse chaser, an astronomer who has been planning eclipse trips 3 years in advance for most of his career, picked Zaragoza specifically because the landscape reminded him of the semi-arid hills of Southern California. Open, dry, low rainfall, and about as reliable as European weather gets in mid-August. Madrid and Barcelona, despite being Spain's 2 biggest cities, will not see totality. They'll get something close. 99.9% of the sun blotted out, still an extraordinary sight, still worth stepping outside for. But not the real thing, not the corona, not the darkness. Just outside totality, the sun's disk is still bright enough that the sky never truly goes dark and the safety glasses never come off. It's the difference between watching a sunset and standing at the edge of a total eclipse. People who understand what totality actually feels like will tell you that difference is enormous, not incremental. A partial eclipse, even a 99% one, is a curiosity. A total eclipse is an experience that rearranges how you think about the sky. That's exactly why an estimated 10 million people are expected to be somewhere within or very near the path of totality on the day. A mix of residents living directly under the shadow and a wave of domestic and international travelers who have been booking accommodation for well over a year. And the numbers around that travel wave are staggering for a country of Spain's size. Impact studies commissioned by Spain's own Ministry of Economy estimate the eclipse could draw somewhere between 446,000 and over 1 million additional visitors, generating net economic benefits estimated at anywhere from 350 million to over 400 million euros. And that's just for this single event. Factor in the 2 eclipses still to come, a total eclipse crossing Spain again in August 2027, and an annular eclipse in January 2028. And some economists are projecting a combined tourism impact exceeding 1.3 billion euros spread across accommodation, transport, and hospitality over the next 3 years. Airbnb has reported an 830% surge in searches for rural accommodation along the eclipse corridor. In some towns near the path, restaurant reservation platforms have logged booking increases of nearly 1,800%. Rural hotels and guest houses that would normally be sleepy in mid-August have been fully booked for over a year. There's a bigger story hiding inside those numbers, and it's about geography as much as astronomy. Spain's tourism industry has spent decades funneling visitors toward the same handful of destinations: the beaches of the Costa del Sol, the crowded streets of Barcelona, the sun loungers of the Balearics in high season. The path of totality runs almost entirely through what Spaniards call España vaciada, or emptied Spain, vast inland regions that have spent the last half-century losing population, watching young people move to the coasts and the cities while rural towns quietly hollow out. For 2 minutes on an August evening, those same overlooked towns are suddenly the most valuable real estate in the country. Local officials in Castilla y León and Aragon are treating the eclipse as a once-in-a-generation marketing opportunity, a chance to put remote villages in front of a global audience and maybe, just maybe, convert a few of those visitors into people who come back, who invest, who remember that there's more to Spain than its coastline. The Spanish government has gone as far as launching an official information platform dedicated entirely to guiding travelers safely and sustainably through all 3 of the upcoming eclipse events. Sustainability, in fact, keeps coming up in every planning document tied to this eclipse, and for good reason. A sudden influx of visitors counted in the hundreds of thousands, funneled into small rural municipalities with limited infrastructure, creates real strain on roads, on water, systems, on emergency services, on fragile natural landscapes that were never designed to host a festival crowd. The director of Spain's Starlight Foundation, an organization focused on protecting dark skies and promoting responsible astrotourism, has been blunt about the expectation. Enjoy the eclipse safely and responsibly and leave the places you visit exactly as you found them, or better. Practical advice being pushed hard by regional authorities includes using public transportation or carpooling instead of driving in personal vehicles, packing out all trash, rather than relying on rural areas to handle a sudden surge in waste, respecting wildlife and protected natural areas, and avoiding unnecessary artificial lighting on the night itself, both to preserve the atmosphere of the event and to protect nocturnal ecosystems. Now, about the weather, because weather is the single biggest wild card hanging over this entire event, and anyone who has chased eclipses before will tell you it's the variable nobody can fully control. Roughly 2/3 of this eclipse's path runs over open water, which is a serious problem for ship-based viewing. Cloud cover over open ocean is notoriously difficult to predict, and even harder to escape once you're out there. On land, the picture is more hopeful, but far from guaranteed. Meteorological analysis going back more than 2 decades shows a strong east-west gradient across the path. Cloud cover averaging around 85% off the coast of Ireland, dropping to something closer to 60% as the shadow approaches Spain, and continuing to improve the further inland and the further east the shadow travels. Spain's Atlantic-facing north coast, the so-called green belt around Galicia and Asturias, sits in a genuinely humid maritime climate zone, where cloud cover regularly exceeds 50% even at the height of summer. It's beautiful country, green and dramatic, but it is statistically one of the riskier places to plant your tripod for this particular event. Move inland, though, and the numbers shift dramatically in your favor. The interior plateau in the Ebro Valley, sheltered by the rain shadow effect of the Cantabrian Mountains, see cloud cover drop to somewhere between 15 and 30% on a typical August evening. The Meseta cities, Burgos, Palencia, Valladolid, have historically enjoyed roughly a 35% chance of entirely clear skies right around sunset on this date, which sounds modest until you compare it to the coast. And then there's Mallorca. Palma de Mallorca, sitting out in the Balearic Sea at the very tail end of the eclipse path, offers what meteorologists describe as the best combination on the entire route. Reliable Mediterranean sunshine, cloud cover averaging only around 20%, and, as a bonus, the longest remaining stretch of totality left anywhere on the Spanish portion of the path. It's part of why coastal spots like Serenal Beach are shaping up to be one of the most heavily attended observation points in the entire country. But even a clear sky forecast doesn't guarantee a clean view because of that low sun geometry we talked about earlier. Meteorologists working on this eclipse have pointed out something that catches a lot of first-time eclipse chasers off guard. Normal cloud forecasts describe what's happening directly overhead, but because the sun will be sitting so low on the horizon during totality, what actually matters is the entire line of sight stretching out toward the west, sometimes hundreds of kilometers of atmosphere between the observer and the sun. A location could have a perfectly clear sky straight up and still lose the eclipse to a distant cloud bank sitting low on the western horizon, invisible in a standard forecast but directly in the way of the setting eclipsed sun. Specialists have been building line-of-sight visibility models specifically for this event, layering in low, medium, and high cloud data to estimate, for every point along the path, the real probability of an unobstructed view, not just clear skies, but a clear horizon. There's also the matter of atmospheric dust. Late summer in Spain occasionally brings what locals call calima, plumes of Saharan dust carried north on southerly winds, sometimes tinting the entire sky a hazy orange and cutting visibility dramatically, especially in the south. A newer and increasingly common variant comes from wildfire smoke, which can produce a similar hazing effect. Neither phenomenon is common enough to be a top-line worry, but both sit in the back of every serious eclipse planner's mind heading into eclipse week. The practical upshot of all this uncertainty is that most experienced eclipse chasers aren't picking one single spot and committing to it blindly. They're building what amounts to an escape plan, identifying a primary viewing location with a strong historical weather record and at least one, often two, backup sites within a reasonable drive, so that if satellite imagery on the morning of the 12th shows a cloud bank rolling into the primary site, there's still time to relocate. Real-time satellite data from European meteorological services becomes critical in those final hours, and eclipse guides are urging anyone planning to chase clear skies to make any relocation decision by mid-morning. At the latest, both because driving conditions on eclipse day are expected to be chaotic and because totality doesn't wait. It arrives at a fixed moment right around 8:30 in the evening local time, and there's no second chance if you're stuck in traffic when it happens. Which raises the traffic question directly, because Spanish authorities have been sounding warnings about it for months. With millions of people converging on a relatively narrow corridor of small towns and secondary roads, gridlock is considered close to inevitable on the day itself. High-speed rail is being pushed as one of the more reliable options for travelers heading to totality. Spain's AV network connects major cities in a fraction of the driving time, and for travelers whose destination sits near a station, it removes a huge amount of uncertainty from the day. For everyone else, the advice from tourism boards and eclipse guides alike is consistent. Arrive early, ideally the day before, secure your parking or your viewing spot well ahead of time, and treat the day itself less like a quick day trip and more like an extended outdoor event. Pack food, water, and patience, because once you're in position, you don't want to be the person stuck in a line of cars still trying to reach a viewing site when the moon's shadow arrives. Now, about actually looking at it, because this is the part where the stakes are genuinely serious, not just logistically inconvenient. Outside of totality, meaning during every single moment of the partial phases, both before and after, looking directly at the sun without certified eclipse glasses or an equivalent solar filter can cause permanent eye damage, even when the sun is 99% covered. The 10,000th of the sun's surface still visible during a deep partial eclipse is still bright enough to burn the retina, and because there are no pain receptors inside the eye, people can do lasting damage without feeling a thing until it's too late. Certified eclipse glasses meeting the International ISO 12312 safety standard are the only reliable protection for the partial phases, and health authorities across Europe have been repeating that message for months as demand for glasses has spiked. The one and only exception, the single moment when it becomes safe to look at the sun with the naked eye, is during totality itself. Those brief 1 to 2 minutes, and only within the path of totality, when the moon completely covers the sun's bright disk, and only the faint, ethereal corona remains visible. The instant that first sliver of direct sunlight reappears at the end of totality, glasses need to go straight back on. For anyone outside the narrow path of totality, which includes most of Europe, since the partial eclipse will be visible across a huge swath of the continent, along with parts of North America, the Arctic, and North and West Africa. The entire event will be experienced as a partial eclipse, start to finish, glasses required throughout. Madrid and Barcelona fall into this category, along with essentially every other major European capital. Even a 99% partial eclipse is a genuinely striking thing to witness, with daylight taking on a strange, muted quality and shadows sharpening in odd ways, but it will never produce true darkness, never reveal the corona, and never allow the naked eye viewing that makes totality so singular. For those who can't make the trip to Spain, or who simply want a front row seat without leaving home, live coverage is expected from multiple space agencies and observatories, with broadcasts beginning hours before the moon's shadow ever reaches the Iberian Peninsula, tracking the eclipse's progress from its opening moments over Siberia and Greenland all the way through to its final act over the Balearic Sea. Expect live telescope feeds from multiple points along the path, expert commentary explaining what's happening in real time, and, weather permitting, the kind of footage that ends up replayed for years afterward in documentaries, in classrooms, in the opening minutes of whatever gets made about eclipse chasing next. It's worth pausing for a moment on why any of this actually matters beyond the spectacle, because total solar eclipses have never just been about the view. They're one of the very few moments when scientists on Earth get a completely unobstructed look at the sun's corona, the wispy outer atmosphere that streams millions of kilometers out into space and that remains, even now, one of the most stubbornly mysterious regions in all of astrophysics. The corona is somehow hundreds of times hotter than the sun's visible surface, sitting just beneath it, a temperature inversion that violates every intuitive expectation about how heat should behave, and one that solar physicists still don't fully understand. Normally, the corona is drowned out by the overwhelming brightness of the sun's disk, invisible except through specialized instruments. During totality, with the moon acting as a perfect natural occulting disk, the corona becomes visible to instruments and to the naked eye alike, in a way that's almost impossible to replicate. Artificially. Every total eclipse becomes a rare, time-limited research opportunity. Solar physicists, historically, have used these brief windows to study coronal structure, to hunt for transient jets and streamers, and to refine models of the solar wind that ultimately affects satellite operations, power grids, and space weather back here on Earth. There's historical weight to this particular eclipse, too, beyond the raw statistics. The last total solar eclipse visible from mainland Europe happened on August 11, 1999, tracing a path through parts of the UK, France, Germany, Austria, Romania, and Turkey. An event that, at the time, drew similarly massive crowds and left a generation of Europeans with vivid memories of standing in sudden, midday darkness. For anyone who witnessed that eclipse as a child, 2026 represents a kind of full circle moment, a chance to stand under totality again as an adult, or to bring their own children along for a first experience of something most people go their entire lives without seeing even once. And for Spain specifically, the wait has been longer still. The last time totality touched Spanish soil was 1905, a genuinely historic gap, meaning this eclipse isn't simply rare in the ordinary sense that all total eclipses are rare. It's rare even by the standards of a country's own astronomical history. What makes the next few years even more unusual is that this isn't a one-off. Spain sits at the center of what astronomers have started calling a celestial trio. Almost exactly 1 year after this eclipse, on August 2nd, 2027, another total solar eclipse will sweep across Spain, along with parts of North Africa and the Middle East, and this one will be notable for an entirely different reason. An extraordinarily long duration of totality, among the longest of the 21st century, stretching past 6 minutes in parts of Egypt. Then, on January 26, 2028, an annular solar eclipse, the kind that leaves a bright ring of sunlight visible around the moon rather than blotting it out completely, will be visible from Spain and Portugal as well as parts of South America. 3 major solar eclipse events touching the same country. Within roughly 18 months is, by any measure, an extraordinary astronomical coincidence. And it's one of the central reasons Spain's tourism authorities are treating 2026 not as an isolated event, but as the opening chapter of a multi-year astrotourism strategy. After 2026, the next total solar eclipse visible from Spain won't arrive until 2053. So for residents who miss this one or whose local weather doesn't cooperate, the backup opportunity in 2027 genuinely matters, because the one after that is a generation away. So here's where things stand, just days out from the event itself. Reliable short-range weather forecasts have only recently become available, with meteorological agencies typically able to offer a meaningful outlook starting around 10 to 14 days before an event like this, and forecasters and eclipse chasers alike have spent the final stretch refining their predictions hour by hour as satellite data updates, Millions of travelers are already in motion or fully positioned. Rural accommodation across northern and central Spain has been booked out for well over a year in the most desirable towns. Restaurant reservations in Eclipse Path towns have surged by orders of magnitude compared to a normal August, and emergency services and traffic authorities across half a dozen Spanish regions are bracing for what may be one of the largest simultaneous population movements the country's rural interior has ever experienced. There's a human dimension to all of this that's easy to lose inside the statistics, and it's worth sitting with for a moment. Eclipse chasing has quietly grown into a genuine subculture over the past few decades. A loose, global community of astronomers, amateur photographers, retirees, and obsessive hobbyists who structure entire chunks of their lives around chasing these few minutes of darkness wherever on Earth they happen to fall next. Some of these people have seen a dozen total eclipses or more, tracking storm systems and airline routes years in advance, treating a 2-minute astronomical event with the same seriousness other people reserve for a wedding or a career move. For them, this Spanish eclipse has been circled on the calendar since well before 2026 even began, not because Spain is an exotic destination, but because mainland Europe hosting a total solar eclipse at all is a genuinely uncommon event, one that won't repeat again after the 2027 follow-up for the better part of 3 decades. Tour operators built entirely around eclipse travel have sold out multi-year package trips to Zaragoza, to the Balearics, to quiet farmland outside Burgos, often years before this week ever arrived. Then there's the much larger group of people for whom this will be a first eclipse entirely. Families driving out from Madrid or Barcelona for the day, students on summer break, curious travelers who happened to be in Europe already and rearranged their plans once they realized what was coming. For a lot of these first-timers, nothing anyone tells them beforehand quite prepares them for the actual moment. People who've experienced totality consistently describe a strange, disorienting shift in the final seconds before the sun disappears completely, a rapid darkening unlike any regular sunset, a sudden drop in temperature as the sun's warmth vanishes almost instantly, birds and other wildlife reacting as though night has genuinely fallen, and then, right at the edge of totality, a brief flare of light around the moon's silhouette known as the diamond ring effect, followed by the corona blooming into view. It's an experience repeatedly described less as watching an astronomical event, and more as feeling one happen to the world around you. Scientific interest in this particular eclipse extends well beyond the general study of the corona, too. Solar researchers have been using the run-up to August 12th to coordinate multi-site observation campaigns, positioning instruments at various points along the path specifically to capture the corona from slightly different angles and altitudes, building a more complete three-dimensional picture of coronal structure than any single observing site could produce alone. Some teams are focused specifically on coronal mass ejections and the fine structure of solar streamers, phenomena directly tied to space weather forecasting, the same science that predicts disruptions to satellite communications, GPS accuracy, and power grid stability here on Earth. Others are using the eclipse as an opportunity to test new imaging and spectroscopy equipment under conditions that simply can't be replicated in a lab, however sophisticated that lab might be. Universities across Spain, alongside international partners, have organized public science events timed to the eclipse in cities like Zaragoza, blending genuine research activity with public outreach aimed at getting as many people as possible engaged with the science behind the spectacle, not just the spectacle itself. None of that changes the fundamental, almost absurd asymmetry sitting at the center of this entire event, though. And all of it, the traffic plans, the cloud forecasts, the elevation maps, the hotel bookings, the solar glasses stacked by the register in every gas station along the path. All of it is in service of something that lasts, at most, a little over 2 minutes. That's the strange math at the heart of every total solar eclipse. An event with a footprint spanning continents, an economic impact measured in the hundreds of millions of euros, months of planning by governments and scientists and ordinary families alike, all converging on a window of darkness so brief that most people spend the 2 minutes simply staring upward, saying nothing, trying to hold onto the sight of a black hole where the sun used to be, ringed in silver light, hanging low over a Spanish horizon that hasn't seen anything like it in over 100 years. Whatever happens with the clouds on the 12th, whatever the traffic looks like on the roads into Burgos or Zaragoza or the beaches of Mallorca, that basic fact isn't going to change. For a couple of minutes on an August evening in 2026, the moon is going to put out the sun over Europe, and everyone standing in the right place is going to watch it happen together.